radiopharmaceutical targeting and Nectin-4, and this is really excellent in a sense that we're thinking that it's really targeted, and then it's gonna be having the behavior like that of how an antibody will be. But the problem with an antibody, for instance, is that it can have immunogenicity by staying longer. But this one there is GFR, which is good, which is faster. Then that really you've got the best of both. And this is how radiopharmaceuticals are going forward. But of course, aided by imaging that is really good to select the patients well. And you can see that this really get to address the problem. And clearly when you do so as well, it's important that as we have shown in the multi-center studies of warmth, that really there are various places that will start late, others early, and so on. Try and see what you can treat in your case. In our setup, for instance, patients, because they come early and they might not be amenable to chemo, or they might also not be happy with hormonal therapies, they may need virus therapy. So targeted radionuclide therapy might start to move as an early stage therapy. And we, as on a theranostic day, we have to realize that we shouldn't be fixated. As we said, non-polarization is important. So it's how we look at it. And to this effect, you can see that FDA in itself has already, as we speak now, approved that actually it can be in earlier use. This is a really big win for us, because in the past, as it was approved, Pluvicto, it was really people must do everything else, and just before they demise, then they can come to you. So we can then extend their life in that way. I'm so happy with this FDA approval. It's one of the celebrations that we should have on this theranostic day. This is really amazing. And then, of course, as you can see, we have demonstrated, this is a meta-analysis that demonstrates what has happened. But in our group, because we are contextual, we're treating what the community needs. We were demonstrating, of course, a bigger PSA of response above 50 than the other groups, because it was in therapy naive patients compared to multiple lines, as you can see, as it decreases indeed. So this is what has happened with actinium, and then I'm glad, as we have seen, it is now happening with lutetium. This is the type of way we should be thinking. The sequencing must change. Where do we put our patient based on real science, not on because it is done like this for no explanation. But we mustn't forget the soil, as we have said. So, I mean, cancer is like a non-healing wound. So you cannot just address the cells, we must address the soil around it. And FAP is really one of the things that we must also continue to understand going forward, how we use it. But it's not only FAP and other potential, of course, tumor microenvironment tracers. So this slides demonstrate clearly, as you can see, that when you're having a conventional FDG compared to FAP, you can see other lesions, see them more, and then of course you can see the discordant lesions, and you can work out whether you want to combine, and that's probably going to be how it is, combining the chemos and FAP, because can be FAP only, obviously, if we are treating this, and or with another radionuclide, who knows, as we develop. This is going to be that situation of, as we treat, it's going to be either combining the isotopes themselves, combining different vectors, and combining different pathways, as we are demonstrated. So we have seen with various studies from CXCR4 by some of our colleagues across the country that clearly hematotoxicity, hematological and other solid cancers will be addressed. So South Africa was highlighted as such when we had a highlight country in SNMMI last year, and we are excited that we could demonstrate some of the good situation of the tumor microenvironment as we demonstrate here. To this effect, this is an example with one of our partners, because going forward, as we have said, it's a quadruple. I mean, the industry here, as you can see, with the industry's tracer developing and seeing that FAP is essential, but we know the problem of FAP, that it was in and out. So to make it stay longer, and as you can see, the 144, it's still there, but also together can try and see to develop various smaller optimization of the tracers to make sure that we limit the non-target effects in this particular. It is exciting that we can play around with this, and we can see clearly, as one has said, that with the better and clearer cameras, you clearly then can let the patient lie for fewer times. So in that way, they can keep on coming without any problems. And clearly, as we do so, we, as per your question, the future is that nothing is spared from evolving. us as colleagues today, we should evolve or else we become irrelevant. But the tracers, we can't keep on speaking PSMA only. We can't keep on speaking prostate only. So it's going to be multiple tracers that will be playing in the space, as we have seen in the Novartis slide, but such as in bladder cancers, I mean, demonstrating even the brain metastasis is going to be important. And then, of course, which means we can see it. But the one thing that we have to say that although we do see it treated, but I think going forward, especially with the micro environment, there is going to be an effect of treating what we don't see as well. Because obviously, if the micro metastases that are going to be there, it's going to be an exciting space of combining the vectors that goes for the cells as well as the microenvironment. Such as in the slides, we can play with various tumor microenvironment targeting radioligands in our situation, and so is many people. And therefore, we are likely to participate in drug discovery, and then, of course, with good dosimetry and select our patients well. And this is going to be enabled, of course, clearly by AI. This is going to be an important aspect of how AI is going to really make sure that the cameras are used well, the radiopharmaceuticals are really developed a bit better. So this is, again, an example that we are showing in our situation. We've got other drugs such as olaparib for BRCA mutations. You can't just give that drug. It's very expensive. So going forward, it's, again, nuclear medicine, as I've said, is going to be one of the pillars and core. So you can image and say, yes, you can go ahead and give olaparib. And you can also, again, similarly, if we go and work out a dose, engage in OJA therapy, perhaps with iodine 123 is one of those, but perhaps not necessarily one of the strongest. There are various other isotopes we can think of, but there is a potential for this. But importantly, we can select these patients, and then for other colleagues, but also for ourselves in theranostic, including in prostate cancers that might not be responding well, which is a big problem. So to extend that lifespan without increasing the toxicities to the patient, it's important to image them first, and we can do so. And this is how it has to advance in this particular instance. So in ending, as one goes to end, Maxim, is that as we engage in newer technologies, as we go forward, it will be important that we communicate well, but communicating is by listening carefully. As I say, listening for real. Communication is what is said rather than what is said more. So it's and in that way, as you can see with these beds, you clearly can, we can redefine modern cancer care. We can, of course, address the heterogeneity that is there and the resistance. And clearly, it's not going to be either nuclear therapy only, it's going to be combination therapies. And then AI will definitely revolutionize precision oncology, because we can stratify, we can repurpose the drugs. The repurposing of the drugs, it's an important, I mean, trastuzumab in itself, it's repurposing, taking a drug that might be on the sideline and taking it and bringing it with radioisotopes. As we really realize that the antibody drug conjugate, the ADC, that is now playing into a big space, but a lot of the ADCs actually are going to be what we will repurpose in nuclear medicine. And then the payload will therefore be radionuclide therapies rather than the ADCs themselves, which are really having some toxicities. But as we do that as well, it's important that AI will be there. And then, of course, we can do radionuclide therapies, but the human factor will even matter more to actually make sure that theranostics goes forward. So the communication cannot be replaced by AI effectively. I would then say the colleagues are welcome to hear more of this next year, 29 January at Cape Town. Although one is in Pretoria, but of course, as you can see, Cape Town is very, very beautiful, as we often you work in Pretoria and play in Cape Town. Thank you.
I think that that was pretty good. He's covered a lot there, and it's very difficult. And I'm watching the questions coming in at the moment. He has covered quite a lot of information there, and he's done that in a relatively quick time frame as well, which is quite impressive. What I was most probably just going to sort of go back to front, I suppose, with some of the questions and look at some of the questions that are a little bit easier for me to answer. So my background, I was previously a nuclear medicine technologist or a nuclear medicine scientist, depending on the graduation time frame. So I did practice quite a while, and then obviously joined GE in multiple different roles in and around, started applications and moved to different roles across clinical marketing as well as product leader and things like that. I think one of the very interesting questions that just came in the last couple of minutes there was, what's the role of AI, or where is the role of AI in theranostics? And I think he touched on it in that last slide ever so briefly. And I think he did it very nicely in regards to it's in conjunction with a human, I suppose is the general summary there. So some of the AI tools that are in development, some of the ones that are currently available, they are very, very good. They're amazing. But they still need that interpretation. They still need that human input. They need that person that Professor Sathaki mentioned multiple times. They need that person to come together, right? To communicate, to bring people together, to be a community type approach, whether you do multidisciplinary meetings. You need that coming together. You need the experts in different fields to come together to get the best patient outcome. So, at the moment we see AI implemented into auto segmentation quite a lot. And I think that's to make theranostics, to make quantitation every day, or to enable quantitation to be used more readily. I think that is one of the most important steps for AI at this stage, is enable auto segmentation. We don't want a physicist sitting behind a computer for an hour to work up one patient. We want that segmentation to be easy, and we want it to be seamless. We have those at the moment. We have that functionality both on our current reporting infrastructure as well as the MIM reporting infrastructure as well. So I know AI will develop in that space. Obviously, there's reconstruction technologies using deep learning, and also there will be some kind of auto sort of reading or recommendation. So we most probably see it down that path, but definitely not replacing the human being. I think, again, I'm just going to go backwards through some of these questions. It's a little bit easier for me. And again, I think this is a question he touched on, and it was around what therapy agents, does he see now and sort of in the future. And he talked about some agents that, I'm based in Australia, and we've got some amazing institutes in Australia that are very, very advanced in what they're offering in regards to sort of the worldwide spectrum of theranostics. But he talked about some agents that were actually right at the forefront, and what's coming next. He's already using, which was amazing. And I think, there's a lot of focus on actinium, and I think one of the earlier questions that was around actinium was, can you image it on SPECT CT cameras? And obviously he showed an image on SPECT CT of actinium post therapy. So that is correct. Is it easy to image, or is it a great imaging agent? Most probably not. I think you had a look at his images. They're possible, but most probably, you're not getting the same kind of definition or conspicuity of lesions that you're getting with other sort of much more suitable imaging isotopes. But he did touch on actinium. He spoke about lead. He spoke about the pharmaceutical FAP or FAPI quite a lot. And I think these are the kind of agents that are either in use if you're lucky enough to be in South Africa, but these are the kind of agents that there's a lot of focus and research being worked on at this stage. I think one of the other ones, he also spoke a little bit around the HER2 receptor. I think if you looked at one of his earlier slides, I think breast cancer, there was, I think 30 or 40 clinical trials that were currently in progress around the world, which is phenomenal. I have no doubt that a lot of them are looking at the HER2 receptor and how we better label that and image that. I think the other sort of methodology, or the other component of theranostics that he touched on ever so briefly, and I know there's some studies, and I know some of the Australian team is, or some of the Australian customers are looking at it as well, is almost a combination of immunotherapy combined with theranostics as well. So I think that's where we're looking at getting some, some good answers, and then potentially getting good outcomes for patients is when we're looking at combined therapy. Cool. I'm just going through some of the questions as well. So I think he touched very much on the investment needed for theranostics, and he covered it very well. And I think the question here is, what kind of investments is needed, and then how do you prioritize the investment across the facility and the equipment, and what's most important? I don't think I have a good answer for that, right? Like it is a very difficult question. He obviously has some very, very high-end equipment. He was talking about digital detectors on his SPECT CT. So he definitely prioritized investment on the SPECT CT side. But he also spoke about having a lab that had the right facilities to enable radiopharmaceutical labeling as well as handling of those kind of high energy or huge amounts of radioactivity for these therapy scans. So I think without having a great answer, I think he summarized it quite well in regards to it's a balance. It is definitely needs to be aligned, or the investment needs to be aligned to your priorities. And then I think he also alluded to talking to the community and also looking at the kind of cancers that you have in your community. And I think this is something that at least the Australian market can look at. We have a very, very high prevalence of melanoma, much more higher prevalence of skin cancer than most probably any other country in the world. And I think, just to extrapolate a little bit further on what he was saying, if you're setting up a clinic in Australia, it's most probably a little bit different or completely different to setting up a clinic in Japan, where they have a very high prevalence of thyroid cancer, compared to setting up a clinic in South Africa. And I think it's, again, as he spoke a lot about it, is bringing the community together, listening to each other and working together around what your sort of community or what your facility can offer to the local patients. And as I said, I'm working backwards through the questions, so I do apologize. And this is probably the last one we can get to before we most probably need to close the session out. But there was a question early on, I think it was associated with an image around where does technetium PSMA sit against other diagnostic PSMA agents like gallium and fluorine. And I think, again, this is most probably a question that needs to be sort of answered in regards to where you're located and what resources or infrastructure you have to offer. I think he showed a very nice case showing the benefits of technetium PSMA over doing a technetium bone scan and showing some more lesions, which is exactly what we'd expect, and it's exactly why doing gallium or fluorine PSMA is now much more prevalent than doing some staging using conventional SPECT CT. But I think where we know it sits is in the absence of PET CT. If you don't have access to that, and we know, as I said, I cover Australia and New Zealand, and there are some more regional or rural sites. And in the absence of a PET CT, I think technetium PSMA plays a very significant role. And I think it's more around what you have located and what you have access to. And then obviously there is a very big socioeconomic play there as well in regards to the finances required. So I think everybody here would very much know and appreciate there is a different cost associated with running a PET service compared to running a SPECT service. And I think this is where we can in potentially somewhat regional, rural facilities still offer a patient a very, very good outcome in regards to that diagnostic scan. So if there are questions that I haven't got to, we'll get to them later. We can respond via email, as we said earlier in the slides, and we can even put you in touch with some local GE healthcare representatives, which may be able to answer it a little bit better and a little bit more regionally ideal than what I can. So without further ado, I will sort of come to, we will wrap this webinar up. This webinar will be available recording. If you've managed to watch it all, that's great. If you've had to skip out for a little bit, if you want to share it with your colleagues, please see the QR code here or reach out to your GE Healthcare representative for a WeConnect login. And then, as I said just before I close, we would like to hear from you. We want to get any feedback that you want to share. As I said, it is sort of closed off for us, so it's for our learning ability. There'll be questions there associated with the format, the information, and the content. So please help us provide more webinars and more suitable webinars in the future. Thank you very much for your time. Very much appreciate it. And any questions, please follow up as best as possible. Thank you very much.